Alright, in today's video we are going to talk about vector, its addition, subtraction, and scalar multiplication. Now, scalar is an object with size but not
direction,
for example, temperature, 3 Celsius, mass 5 kg. There is an object with both size and direction. For example, displacement 5 meter north. This is the size and this is the direction. Velocity and acceleration. We typically represent vector by an arrow. For example, vector A is 5 meter north, something like this. And vector B is 3 meter east, something like this. To add A and B, we first draw A, join A with B, and we piece them together by combining from the tail of A towards the head of B. So this is the addition. Now, how about B plus A? We take B and then we join that with A. We piece them together by taking from tail of B and towards the head of A. So this is B plus A. A minus B, which is equivalent to A plus negative B. We note that negative B is the opposite direction. So that means we are doing the same thing. We draw A and then taking the tail of A and move that towards the head of B. So now this is A minus B. All of these are in geometric form, which can be a bit difficult once we add more vectors. So another way to show this is through component form. Identify how many directions are we dealing with. Well, there are two directions, the east and west direction, and then north and south direction. That means we would have two placeholder. This would represent the east, west, and then this would represent the north, south. There is zero movement in east and west, so this is 0. And then there is a movement of 5 meter north. We have a movement of 3 meter east. We have 0 movement in the north south direction. So now it becomes a bit more easier when you want to add A plus B. Then that is equivalent to 0, 5 plus 3, 0. Add this one with this one and this one with that one, and then you will get 3, 5. Let's take a look at some examples. Given A and B, find A plus B, A minus B, and B minus A. A plus B is equal to 2, 3 plus 1, negative 4. We take this 2 and 1, so this would be 3. And then 3 plus minus 4, this would be negative 1. Similarly, A minus B equal to A plus minus B, and this is equal to 2, 3 plus negative 1 and 4. This is equal to 1, 7. B minus A, 1, negative 4 plus minus A, which is minus 2 and minus 3. And this would be negative 1 and negative 7. Okay, what we meant by scalar multiplication is the multiplication between scalar and a vector. So that means 5 multiplied by a vector A. This is a scalar multiplication. Vector A times vector A, this is not a scalar multiplication. Vector A cross vector A, this is not a scalar multiplication. Vector A times scalar is a scalar multiplication. Now this is the dot product, and this is the cross product, and this is scalar multiplication, and this is what we are going to talk about in this video. For example, is vector A is 3, 0, which means it's moving to the east. So what that entails is that if we multiply A by a scalar of 3, then the length of the vector will be lengthened by 3, which means it will be 9, 0. So this would be longer. Similarly, if you have multi-directional vector, B is 3, 5. 3, 5, meaning this is 3, this is 5, then a scalar multiplication with 2 would mean that the length would be double. So this would be 6 and this would be 10, which means we have a longer vector because this would be 6 and this would be 10. Given vectors A and B and C, find B plus 3C minus 2A. B plus 3C minus 2A equal to 2, 1, 1 plus 3 multiplied by 7, 5, 4 minus 2 times A, which is 1, 2, 6. And we can solve the second and third term. 21, 15, 12. Negative 2, negative 4, negative 12. 2 plus 21 minus 2. So that will be 21. 1 plus 15 minus 4, 12. And then we take 1 plus 12 minus 12 would be 1. Our solution. Let's recap. Scalar has just size, no direction. Vector has size and direction. This is, for example, mass, temperature, and this is, for example, displacement, velocity, acceleration. The addition of two vectors involve drawing A combine with B and combining tail of A to head of B. So what that looks like, if this is A, this is A, this is B, from tail of A to head of B. We can also represent this in a component form. If this is 3, 5, and this is 10, 0, then A plus B is a component wise summation. So that means this plus this part and this one plus this part, and you will get 13, 5. Now a scalar multiplication is different from dot product or cross product. Scalar multiplication involve multiplication of scalar and vector, whereas dot product and cross product involve multiplication of vector and vector. Scalar multiplication is the scaling of the vector size / magnitude.